Welcome to the deep dive. Today we're tackling a concept that's really more than just theory. It's, absolutely crucial for writing solid, flexible Java code.
Yeah, especially if you're aiming for those senior developer roles.
Exactly. We're talking about higher order functions, specifically how Java's comparator interface uses them.
Right. It's like passing around instructions, not just data.
Yes, that's a good way to put it. Instructions on how to operate on the data.
Precisely. And while Java isn't, purely functional, it uses functional interfaces really well to get similar benefits. Comparators are a prime example.
Treating comparison logic as a first-class citizen, basically.
Because higher order functions at their core are just functions that take other functions or return them, or maybe both.
And the comparator API is just packed with examples, especially for sorting.
It really is. It's a fantastic practical illustration.
So that's our focus today, how Comparator uses these ideas. We'll look at methods that give us back comparators.
Methods that let us tweak existing ones.
And those really useful static methods right on the comparator interface itself.
Yeah, mastering these isn't just about neat code. It often comes up, in senior Java interviews. It shows a deeper understanding.
Definitely a differentiator. So let's kick things off. How about methods that actually produce comparison logic?
Okay, good starting point. Imagine a typical interview question. You've got a list of strings, you need to sort them, maybe ascending, maybe descending, based on some condition.
Right, like a config setting or something.
Yeah.
How do you build that flexibly?
Well, this is a perfect case for a method that returns a function, or in Java terms, returns a comparator.
Okay, like this code here?
Yeah, let's look at it.
Public static comparators, string compare in direction, open parenthesis, close parenthesis, open curly brace, return, open parenthesis, x, comma, y, close parenthesis, arrow direction times x dot compare to of y, semicolon, close curly brace.
So can you walk us through what's happening? Why is this a good example of returning a function?
Sure. The key thing here, I think, is that compare in direction doesn't do the comparison itself.
Right.
It takes that integer direction, like you said, maybe one for up or next one for down, and its whole job is just to return a comparator string.
Exactly. And the actual comparison logic.
That's in the lambda. Open parenthesis x, comma, y, close parenthesis, arrow direction times x dot compare to of y. That's the comparator implementation.
Right. And depending on direction, it either uses the natural compare to result or it flips it by multiplying by -1.
Clever. So if we had, say, an array of names and wanted descending order, we just call arrays.sort names, compare in direction -1. Let me read that code fully. Arrays.sort, open parenthesis, names, comma, compare in direction, open parenthesis, -1, close parenthesis, semicolon.
Perfect. You're basically asking the compare in direction method to manufacture the specific sorting logic you need right then and there.
It's like a little comparator factory.
Exactly. That's a great term for it. This idea of generating functions or function objects on demand is super powerful for composition.
Yeah, much better than writing two separate comparators, maybe.
Well, think about the alternative. You could maybe put an if statement for the direction inside a single comparator lambda right in the arrays.sort call.
Yeah, you could, but that feels messy.
It can get messy and less reusable. If you need that directional sort elsewhere, you'd repeat the logic. This factory approach keeps things cleaner, more modular.
Makes sense. So that's a key takeaway then, especially for interviews. Look for ways methods can produce these functional interfaces.
Absolutely. It shows you're thinking about flexibility and composition. Now, what about taking logic we already have and changing it slightly?
Okay, so shifting gears. We've seen methods returning functions, now modifying existing ones.
Yeah. Let's say you have a standard case-sensitive string comparator. The interview task is make it case-insensitive and reverse the order.
Right. You could write a whole new one, I suppose.
You could, but is there a more elegant way? Using a method that modifies the existing one?
Okay, like this reverse method concept.
And exactly. Look at this code.
Java. Public static comparator string reverse. Comparator string comp, xy's comp dot. Okay, reading that. Public static comparator string reverse, open parenthesis, compare, close parenthesis, open curly brace, return, open parenthesis, x, comma, y, close parenthesis, arrow comp dot compare, open parenthesis, a, comma, x, close parenthesis, semicolon, close curly brace.
So what's the core idea here?
Well, this reverse method, it takes another comparator, comp, as input, and it returns a new comparator. But the new one defined by that lambda open parenthesis x comma y close parenthesis arrow comp dot compare open parenthesis y comma x close parenthesis. It doesn't really do its own comparison.
Right. It delegates.
Yeah, it delegates back to the original comp, but it just swaps the arguments y and x.
Exactly. So if comp said A comes before B, this new one effectively says B comes before A. We're reusing the original logic, just flipping the result.
That's neat. So for that interview example, we can take string.com compare to ignore case. Read a string double colon compare to ignore case.
Yep, the case-insensitive comparator.
And just pass it to our reverse method. Reverse open parenthesis, string double colon, compare to ignore case close parenthesis.
And boom, you get case-insensitive, reverse alphabetical sorting.
Pretty elegant.
Very. And importantly for interviews, you should also know the comparator interface itself has a built-in way.
Oh, right. The reversed default method.
Exactly. Any comparator instance has it. So you could just call string double colon compare to ignore case dot reversed open parenthesis, close parenthesis. Same result.
Huh. So I have both, like our static reverse and the instance reversed. Any thoughts on why the Java designers did that?
That's a good question to ponder. Maybe the static one is useful as a general utility, if you just have a comparator variable lying around.
Well, reversed is maybe nicer for chaining method calls together, like a fluent style.
That seems like a reasonable distinction. The default method fits very well into that fluent API style that comparator encourages.
Okay, that makes sense.
So now let's get to the real powerhouses, I think. The static factory methods that are part of the comparator interface itself?
Ah, yes. Methods like comparing. These are super handy.
Definitely. So imagine you've got a person class. It has a getLastName method. You need to sort a list of person objects by last name.
You'd use Comparator.comparing.
Right, like this. Comparator.comparing open parenthesis, person double colon, get last name, close parenthesis. Can you break down what that comparing method is doing?
Sure. It's a static method, takes a function as an argument. Here, that function is person double colon get last name.
Which access?
Like a key extractor. It tells comparing how to get the relevant piece of data, the last name from each person object.
And the last name is a string, which is comparable.
Right. So comparing does the heavy lifting. It creates the comparator person that knows to extract the last name and then compare those.
Yeah.
We don't write that extraction in comparison logic ourselves.
Exactly. It focuses on the what sort by last name, not the how. Okay, but what if two people have the same last name? Adams. How do you break the tie? Say, by first name.
Ah, that's where thenComparing comes in. You chain them.
Show me.
You'd write comparator dot. Comparing open parenthesis, person double colon, get last name, close parenthesis. Then comparing open parenthesis, person double colon, get first name, close parenthesis.
See how readable that is? First compare by last name, then compare by first name. Super clear.
Very fluent. Okay, tricky one. What if we want to sort people not by last name alphabetically, but by the length of their last name?
Can comparing handle that?
I think so. They're overloaded versions, right, that take a second argument.
Exactly. A custom comparator for the extracted keys.
So we could do comparator dot comparing open parenthesis, person double colon, get last name, comma, open parenthesis, comma, t, close parenthesis, arrows dot length, open parenthesis, close parenthesis, minus d dot length, open parenthesis, close parenthesis, close parenthesis.
Whoa, let's unpack that.
Okay. First part is the key extractor. Person double colon, get the last name.
Still getting the last name string.
Right. But the second part, the comma, then the lambda, open parenthesis s, comma t, close parenthesis, arrows dot length, open parenthesis, close parenthesis, open parenthesis, close parenthesis. That's a custom comparator for the strings, the last names.
And what does that lambda do?
It compares two strings, s and t, based on their length, s length.
Perfect. So you extract the key, then apply a custom comparison logic to those keys. Very flexible.
It really is.
Now, you might also remember seeing things like comparing irons, comparing long, comparing double. Why do those exist?
Ah, yeah. Efficiency. Right. For primitives.
Tell me more.
If your key extractor function returns, say, an int or a long, using comparing int or comparing long avoids. Autoboxing.
Exactly. Autoboxing overhead. If you use the general comparing method with a lambda returning int, it would get boxed into an integer object unnecessarily.
So for our sort by length of last name example, a better way might be.
Try comparing it.
Okay. Comparator dot comparing int, open parenthesis, p arrow, p da da da, get last name, open parenthesis, close parenthesis, dot length, open parenthesis, close parenthesis, close parenthesis, close parenthesis.
Nice. The lambda, p arrow, p dot dot, get last name, open parenthesis, close parenthesis, dot length, open parenthesis, close parenthesis, directly returns an int. Comparing lint handles that efficiently. No boxing.
Got it. Performance optimization. Makes perfect sense.
Okay, one last common challenge, nulls. Data isn't always clean. What if the thing you're sorting by might be null?
Right. Like maybe person has a get middle name, which could be null. How did the comparator help there?
It has specific tools, the static methods nullsFirst and nullsLast.
Ah, okay. They sound descriptive.
They are. They take an existing comparator and wrap it, basically, returning a new one that knows how to handle nulls, putting them either at the start or the end.
So for sorting by middle name, putting nulls first.
How would you build that using comparing and say nullsFirst?
We'd start with comparing person.getMiddleName. So comparing open parentheses, person, double colon, get middle name.
Okay, that extracts the potentially null middle name. What comparator do you use for the actual middle names when they're not null, and how do you bring in nulls first?
Right. So the second argument to comparing needs to be the null handling comparator. That would be nullsFirst. What goes inside nullsFirst? We still need to compare the non-null names alphabetically.
What provides standard alphabetical comparison for strings?
Oh, comparator.natural order.
Exactly.
So the whole thing is comparing open parenthesis, person, double colon, get middle name, nullsFirst, open parenthesis, natural order, open parenthesis, close parenthesis, close parenthesis, close parenthesis.
Perfect. Let's break that down one more time.
Okay. Comparing extracts the middle name. The second argument, nullsFirst, open parenthesis, natural order, open parenthesis, close parenthesis, defines how to compare them.
And what does nullsFirst natural order itself do?
It creates a comparator that uses natural order, alphabetical for strings, for non-null values, but treats any null value as coming before any non-null value.
Precisely. So all the people with null middle names bubble up to the top. And of course, nullsLast does the opposite. Can you think of a scenario where you'd want nullsLast?
Maybe sorting tasks by priority, where null means not prioritized yet, so you want them at the end.
Good example. Or maybe sorting items by a date completed, where null means not done and should appear last.
Right. Makes sense.
So just to recap our whole deep dive here.
Now let's summarize.
We looked at methods that return comparators, like our compare and direction factory.
The methods that modify existing comparators, like using reversed or writing our own wrapper like reverse.
And then the really powerful static factory methods in comparator, comparing for key extraction.
Then comparing for chaining criteria.
The primitive versions like comparing Gradient for efficiency.
And the null handlers, nullsFirst and nullsLast.
Exactly. Understanding and using these is, as we said, pretty key for writing clean, adaptable Java, especially around sorting.
And definitely key for demonstrating that senior level understanding in interviews. It's about knowing why these patterns exist and how they help.
Absolutely. Being able to explain the benefits of composition, avoiding boxing, handling nulls gracefully that shows depth.
So for you listening, as you work on Java code or prep for interviews, really think about where you can apply these higher order function ideas with comparator.
Yeah, look for chances to make your comparison logic more flexible, more readable, more reusable using these techniques.
Maybe even think beyond basic sorting of lists. Where else could creating or modifying comparison logic dynamically be useful in more complex algorithms or data structures? Something to chew on.